Hello, my name is Satray, and this is the Task1 given by the GRIP program organized by the Sparks Foundation. In the Task1, I have to predict the percentage of an student based on the number of study hours. And the objective is we have to use the simple linear regression and predict the score based on the study hours per day. This is my GitHub account, invest474, and I have uploaded the my project, that is Tax1, and the name is Student Performance Score. And this is the CSV file that has been provided, and I have completed this project in Jupyter Notebook. So let's start with the project. At first, I have import the required dependencies, and the dependencies are numpy that I have imported as np, and pandas, and matplotlib.pyplot. After that, seaborn, and to ignore the warning, I have imported the warnings. And for 10 train test splits from Ashkelon, I have imported from Ashkelon.model selection, I have imported the train test split, and from Ashkelon.linear model, which is our required model, that is linear regression, that I have imported. And from Echelon.metrics, I have evaluates the errors, and there are three types of error that I have evaluated. That's mean squared error, mean absolute error, and R2 score. pd.readcsv is used to import the dataset, and I have stored the dataset in performance, and now viewing the data. Performance.head gives the top 5 records present in our dataset, and performance.tail gives the bottom 5 record present in the performance dataset. Performance.shape gives the dimension of the dataset, and here 25 is the number of the rows and 2 is the number of the column. Performance.size gives the number of data present in our dataset, that is total 50 records. Total whole 50 records is present, counting the both two columns. And performance.info gives the information of our dataset, and here it represents that we have hours and scores column, and null value, there is not any null values, so no non null. And data types, hour is float data type, score is in data type. Performance dot is null dot sum method that counts the number of the null values present in the performance dataset and sum that null values. Here our both column have zero null value. And type performance gives the data type of our performance dataset, and which is data frame. Dot columns shows the columns or features present in our dataset, and the features are hours and score. In 21, I have used the dot lower method to convert this hour and score into the lowercase and store that values in performance dot column. Visualizing the performance dataset, uh, I have used the C1 as SNS. So SNS dot scatter plot, and I have plotted the scatter plot. And data is our performance data set, and x and y are the x and y axis. And in the x-axis, I have used the first column, that is 0, and in the y-axis I have used the last column, that is represented or given by the -1. This is the scatter plot, and which gives which shows the distribution of our data. And if By comparing the hours and the score, students which study for the less hour has the minimum score, and students which gives priority to the study and study for the more hours also scores the highest percentage. And so represents I have represented this dataset by and applied the regression plot, that is SNS does dot reg plot, and this is performance dataset x and y axis, and this is this regression plot, and the straight line is the best fit line. Hmm. After then I have split the data in x and y, and uh, train test split, that is echelon dot model selection as the train test split, and x and y are the x and y values, and test size that we are going to use to predict the y predicted value later on by using the x test, and the percentage of the test size is the 20%, which means we have splitted our data in train and test, and train is the 80% and test is the remaining 20% of the whole data, and the random state which shuffles the data, and this is the values that are stored in the X train, that is 20 rows, and X test which has the 5 data, Y train has the 20 data, and Y test has the 5 data, and I have converted these data in the data frame from the series value, so that later we don't get the warning or the error, uh, as as size is not good. So later on we have to reshape the data size. We have to reshape the data uh, in the two dimension, and x test y test as the stored value of this data frame. Now the main task, that is creating or forming the model of the linear regression, and linear regression I have used, and this model is stored in the performance score model. I have fed the dataset with the x train and the y train. After then I have predict the x train value, uh, and then I have used r square score, uh, which tells how much data has been represented by our model, that is 95% data has been represented by our model, and this is the prediction error, and that is 95% is uh, represented by this model linear regression. After then I have plotted the regression plot, and the title plt dot title and plt dot show, which gives this this title and x-axis and the y-axis as above. After then I have used y predicted, and this is the base fit line, and it's showing that uh, most of our data falls on the straight line. That's why we have got the 95% of the r square error. After then I have predicted the x test, and this value is stored in the y predict score test, Now metric or evaluating our model, and R2 score again tells that uh, Y test and Y predict score test uh, as shows 94% of our dataset. After then evaluating the errors, that mean absolute error, and that is 6.45. After the mean square error, 44.165 mean squared error, but this is root mean square because square is false, so this is the value of root mean square, that is 6.64. For the y test value and the x test, I have plotted the regression plot. After then y x test and the y predict score, again I have plotted the regression plot. Here we have the five data, and equation of the linear regression is the equation of straight line, that is y equals to mx plus c. Now we have to find the intercept, that is c, and the slope of the equation or the coefficient of the linear regression, that is m. And this x is the independent value, which is our x-axis hours, and y is the dependent value, which is scores. So intercept for this linear regression is 1.75, and the coefficient of the simple linear regression, that is m, is 9.74. uh, and this is the suppose there is the question, what will be predicted score if a student studies for the 9.25 hours per day, and the answer is um, above 91% that student will score. And if we apply the value of the x in our equation of linear regression, again we get the same answer, that student studying 9.25 hours per day will score 92%. Thank you.